adjacent and hypotenuse. Adjacent and hypotenuse. That's AH. Which one of these three have AH? So that means I'm going to use the cosine function to find my answer for this problem. Because in reference to this angle, this is always the hypotenuse. The hypotenuse is always the hypotenuse. It's never going to be anything else. And the leg that I'm looking for is touching that reference angle. So it's adjacent to that angle. All right? So I would say that the cosine of 28 is equal to x over 15 or 15 over x? X over 15. And then you'll have to punch that into your calculator. What do you actually punch in?
15.
Exactly. All right? And you would get 13.2. All right, so x would be equal to 13.2.
Did you grade our last test?
Yes, I showed it to y'all. Y'all filed them. All right. Because right triangles don't always have to be sitting on their bases. They could look like this. Suppose you are looking for this angle. You were told that this is 10 and this is 7. To figure out if you're going to use cosine, sine, or tangent, you start by looking at the angle. Here is your reference angle. Either you know it or you're looking for it. In reference to that angle, do you know opposite, adjacent, or hypotenuse, or which two do you know? Opposite and adjacent. Here is your hypotenuse, and we know nothing about it, and we're not looking for it. So which one is opposite and adjacent? OA. TOA. TOA. So it's the tangent of your angle, which is what we're looking for, is equal to the opposite over the adjacent. Well, is that going to be 7 over 10 or 10 over 7? 7 over 10. 7 is opposite the angle. 10 is right next to the angle, which would mean adjacent to it. All right, and on your calculator, you have to use which button? The shift key. And since we're looking for an angle measure, we have to express it as degrees, and this rounds up to 35 degrees. Okay? Now, we've done lots of practice with these where we were given the triangles. On page 707 and 706, you had to find and solve for triangles, and the triangles were already drawn for you. Now what we're going to do is we're going to take this information, and we're not going to have the triangle. We're going to draw it. You are going to sketch the triangle, and you are going to determine which parts are labeled and what are we looking for. Okay? So, the first thing you need to know is what's the difference between an angle of elevation and an angle of depression. Every problem that you're going to be working tonight is going to involve a right triangle. But you're going to have situations that are described to you. This right triangle, can anybody figure out a story about this right triangle that this could be applied to?
Kite elevates.
Someone's flying a kite, right? Someone's flying a kite. They're standing on the ground, holding a string, and the string goes through the air and is attached to the kite. If I asked you to find out how much string has been released, which part of this right triangle do we label as X? The hypotenuse, because this would be the string, right? If I asked you to find how high the kite is above the ground, this would be how high the kite is above the ground. And I don't know why we would want to know this, but if we were looking for that, this would be the distance From the person holding the kite to someone standing directly underneath the kite. Yes?
Isn't that sometimes like the shadow of a building or something?
We can use that to calculate shadows. Exactly. We could go outside right now and we could use this type of information to calculate how tall a tree is, using shadows and measuring certain things. Okay? All right. Now, if you are standing on the ground, and I want you to think of this. When you say you're looking out over the horizon, that means you're looking how? Straight ahead. All right? So every time these problems are given to you and you say that someone is looking out over the horizon, you need to imagine their eyes. Where are they located? And where would the horizon be? Now here, the person would have to look up to see the kite, correct? All right, so this is called an angle of elevation. Elevate means to raise up. Now in this case, suppose I had one sitting on the top of a building looking down at the driver of a car parked down the street. If I'm asking for the angle in reference to the person on the top of the building, his horizon is looking straight out, correct? So the angle from looking straight out down to the car is the angle of depression, because you would be looking down. Now, for those of you who took geometry last year, let's refresh our memories. For those of you who didn't take geometry, you will learn this next year, so don't freak out about it, okay? This is for the benefit of those who had it. If you have these two lines, your horizon and this dotted line down here at the bottom, and these same side interior angles add up to 180 degrees, what do you know about these two lines? They're parallel to each other. Very good. And two parallel lines, John, do you remember this? Cut by a transversal form alternate interior angles. Y'all remember that? And what do you know about those two alternate interior angles? They're equal to each other. Okay, so with all of that said, if you are given an angle of depression is 30 degrees, that 30-degree angle is nowhere in this right triangle. You need to know something about the right triangle. Well, the person sitting at the top of the building looking down at the car has an angle of depression that is the same as the person sitting in the car looking up to the dude on the top of the building. So if you were told that the angle of depression is 30 degrees, you've basically just been told this, that the angle of elevation in your triangle is also 30 degrees. Now, why am I pointing this out? Because a common error is going to be you have an angle of depression of 30, and y'all are going to want to do this. And that's not right. Okay? And this is why it's not right. We said this was 90 degrees, right? The actual angle of elevation is 30. If this was also 30, does that add up to 90? No. Okay. So, knowing all that, let's start to apply. Okay. You're going to classify some angles. Are they elevation or depression? Angle number 3.
Depression.
That would be classified as an angle of depression because the vertex of this angle is here. So we would imagine a person looking from point H. The horizon would be this, correct? From the horizon, they are looking down to point G. So that would be an angle of depression. What is another angle that would be equal to angle 3?
2, 8.
Angle 8. Because if you have a person at point H and a person at point G, when this guy looks down, he has an angle of depression that is the same as this guy looking